Welcome to the Overdue 5.2 in your journal, note-taking vocabulary practice, page 130. We're going to try a new format here, expand this a little bit, see how it works. We got us corresponding parts up here. We're going to look at that in these orange figures over here too. So corresponding parts, same relative part in congruent or similar figures. We're looking mostly at congruent. Similar comes up later in here, but it does come up. Number 2 here in the blue, parts which map to each other using rigid motion. So you can match this up a couple of ways up here in the orange. You can say, oh, A is my acute angle. That goes to angle C over here. And you can see that matches up. And then you could go, oh, I go down the long straight side, I get to F. I go down the long straight side, I get to B. So angle F matches up with angle B, and so on. Or you could say, you might also notice that, hey, this just requires a rotation. And if I rotate this 90 degrees clockwise, it'll end up looking like this, something like that, and it matches up a lot better with that one, and you can see it. I switched to purple because the red wasn't showing up here. Okay, you can match the rest of these. You should match up angle H. You should be able to match up that with angle D. Angle G is our only one that's left there. That goes with angle E. Excuse me. Properties that we use in here. You've heard me talk about it in class, hopefully. Reflexive property. Anything is congruent to itself. Whether it's triangles or parts. This is triangle congruent, so any triangle is congruent to itself. Symmetric, that basically means, notice, they just turn this around in there. A triangle ABC congruent to DEF, DEF to ABC. That's more language semantics that we don't use right in here. Transitive does come up a lot. If ABC is congruent to DEF, DEF is congruent to JKL, that gives us this one. That works when we have them congruent to the same part. Let's leave those on there. Substitution I mentioned also works is similar to that. Core concept, correspondence, it's got to match up. I took these colors off earlier, I shouldn't. When you write this, C corresponds to D. A corresponds to O, so the order matters on these. You're telling me the relations T, whoa, I forgot to change that back from earlier. T goes to G. Okay, so somebody else might write its different order. They might write it ACT over here. So you still have to match to the same thing. In this one, A goes to O, so that's going to go to O. C goes to D, so that goes to D. T goes to G, so that would be G. So we don't have our cat and dog, we've got our act and ODG, something like that for the ODG. But it's still the same triangles. Angles, you got to be even more careful lining up. You can't just change the order in angles. You always got to have the vertex. If you use 3 letters, the vertex is the center one. This is just filling in these congruences. Give it a try. Don't wait for me. Pause this right now, then come back to it. Or I'm going to pause mine. Is for the angles. T goes to G, angle A goes to O. Try filling in these sides here quick. I'm going to pause mine. They're going to be there when you come back. There you are. Hope you got them right. And remember, try those. The better you get, every question you answer, right or wrong, get better. Focus on getting better. If you got it wrong, Can't show Y, act. I'm just using all these little color code matches that I had in here. Whoops, what did I get rid of there? That angle. And, you know, just looking at that. I also looked at this one a couple of times. You know, it's just like, oh, T's the last one, G's the last one. They match up. Third angle theorems. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are also congruent. So if I've got two angles of one triangle, so that's two angles of one triangle are congruent to two angles of another triangle, that means these third angles are also congruent. You get that for free. If then statements coming up again. So which angles do we have going in here? Fill it in. That would be angle M is congruent to angle Z. Remember, you can call this angle JMK or angle KMJ. That's the same thing. There's no other angles there to confuse it with, so angle M and angle Z are fine. Extra practice matching these up. So just give these a try. I don't have these answers listed for 1 and 2. I do have them for 3 and 4 down here because it's just too easy to give them up. So try number 1. I'm going to fill it in, pause it. When you come back from the pause, the answers are going to be here because I'm going to pause this now myself. And if you can't see, you know, for P and S, first letter to first letter, Q is the second letter, T is the second letter, R is the third letter, U is the third letter. Do it over here. After you get this one filled in, which segment is missing? Each letter's got to be used twice. And each name, figure out which one is missing. Like, let's just do it here together. TU, second and third letters. QR, second and third letters. Now, what's your missing side? Well, I've got, you know, if you can't see it, look at the triangle. You got PQ. There's PQ. You got QR. There's QR. There's your missing side right there, PR. So you know that side PR. I can't write. Find the other one. What's it going to be here? PR. First and third goes to SU, first and third. And we got it. Another way of writing this, they gave us triangle PQR. I have triangle RPQ. Try to fill this one in. Pause it. Answer it. There you go. I should have read the directions first. Identify all pairs of congruent corresponding parts. So that's what we were doing up here. I should have read the directions out to you. I read them to myself. Forget you weren't with me when I read them. Then write another congruent statement for the polygon. So they gave us this one. This is me writing another congruent statement. Over there, you can have multiple ones. Remember, for these ones, you've got to go clockwise or counterclockwise. You can do either one. You can start at any letter on that for number 2. Number 3, find the values of X and Y. So we got these corresponding parts, okay? Now they're not marked as congruent, but we have congruent triangles. If these triangles are congruent, all the parts have to be congruent. We call that CPCTC. I'll explain that another time when I see it come up. But corresponding parts of congruent triangles are congruent. So if you notice here, Y is the second letter, S is the second letter. So angle Y is congruent to angle S. So we know the measure of angle Y is equal to the measure of angle X. So 2x minus 20 has to equal, what's the measure of angle S? Strategic pause. 30. Hopefully you got that. And then you can solve that. Plus 20, That gives me 2x equals 50, so x equals 25. Right much? Okay, so we get x equals 25. So we know that's 25. This is an isosceles triangle, so 30, 30, that's got to be 120. That's going to work too. 2 times 25 is 50, minus 20 gives me 30, it matches up. Same thing over here. Go in here. These are congruent. They're marked. XZ is congruent to ST. They're marked congruent, or TS I said. So their lengths are the same. So 15 equals what? Put it in there. 3y plus 9. I hope you use your strategic pause. Solve it. Again, pause it. Just because I don't tell you to pause it doesn't mean you can't pause it when you see something that you know you're supposed to solve. Always test yourself out. Minus 9, minus 9. That's what Damian Lillard was talking about in that video I showed in class the other day. 6 equals 3y. Always working, always trying to get better. Doesn't matter where or when. So we got 3y divided by 3. 2 equals y. 15, 3 times 2 is 6, plus 9 is 15, so that works. There's my x, there's my y. We can get those. So match up the congruent parts over here. Notice, what does A go to? You can do it. There's my scrambled answers. I forgot to check with those over there. Okay, this one I've done some parts already. So writing a proof and justifying things like we're supposed to do in here, explaining your reasoning, isn't necessarily about writing it out. Writing it out is just saying, hey, this is what I did. Look at the diagram, see what you can get there. We got a lot of stuff given over here. I got marked that down. That's not angle A congruent to angle C, AB, segment AB congruent to segment CD. All that stuff is marked here. And then I also got this right angle here. And I'm knowing right away, hey, you know what? I see I got these 2 triangles here. I got right there, right there. I'm noticing right away, boom, boom. Actually, I need a third one because I've already used 2. That segment is in both triangles. There's my reflexive property. I'm supposed to have that in purple because that matches up with my purple later over here. There we go. Okay, you know what? I've also got this down here. Any right angle, I got another right angle there. I can't forget about that. Those 2 are congruent. And you know what? Now that I got that, I got 1 angle, 2 pairs of congruent angles. That gives me my 3rd angles in here. And those have to be congruent too. Again, going back to those 2 triangles I showed you in there earlier. Right there. Right there. Okay. Now I've got all the parts congruent, so the triangles have to be congruent by definition of congruent polygons. Then you write it out. So the purple one, BD is congruent to BD by the reflexive property. If you said DB, that's fine. Don't worry about that. We're running short on time here. Angle ABD is congruent to angle CDB. All right angles are congruent. I should have had a perpendicular statement up here. I didn't put that in there for some reason, but that was given to us that BD is perpendicular to AC. The blue one, that is my 3rd angle theorem. Angle ABD is congruent to angle CBD, and that is my 3rd angles theorem. And then I got my final statement, theorem 5.4, triangle ABD is congruent to triangle CBD. All the corresponding parts are congruent. I got 3 sides, 3 angles in each of the triangles.